application of machine learning to biomedical signal and image processing. Therefore, I will try my level best. To be frank, I prepared since I have understanding about machine learning. Then I have learned some of the biomedical signal processing applications to machine learning. To especially teach take this 1 hour like presentation. I am not expert in this, but somehow we will link it up. Okay. So.
Okay.
So yesterday we have discussed something, say artificial intelligence, machine learning, deep learning, so many, and again in neural networks, so many different types. At the outset, all these comes under something called automation. Automation means thinking whatever we are doing whatever we are thinking. That involves, say, at the lowest level, something called deep learning. This deep learning is in the direction of multi-layer neural networks, and it is a sub-part or sub-area of machine learning. Again, machine learning is sub-area of artificial intelligence. We know that artificial intelligence is making the machine to behave like human beings by using statistical and neural methods, and therefore you are making computer to behave whatever may be the method. That's where things come, something called automation. And nowadays we have so many words like artificial intelligence, machine learning, deep learning. To that we added one more thing called data science and so on. Let me give a feel of some of the things, so that finally we will be linking up our discussion to biomedical signal processing. You may ask why you need to study all these data science, all those things for the biomedical. Why can't I use directly AI and ML? We cannot directly jump to this your biomedical signal processing application using machine learning. Data science is also involved. And as we said, artificial intelligence says human brain, any technique which enables computer to mimic human behavior. And machine learning, a subset of AI techniques which uses statistical methods to enable machines to improve with experiences. Then coming to deep learning, which is a subset of machine learning, again makes the computation of multi-layer neural network feasible. Nowadays you can see nobody talks about support vector machines. It is not the extension of multi-layer neural network. In fact, it is, even it does not belongs to neural networks. Only thing is the relationship between multi-layer feed-forward neural network and support vector machines is that both are discriminative learning. That is the only thing. Therefore, somehow support vector machines exploration has been decreased. People are moving towards deep learning. AI, machine learning, as we discussed yesterday, it involves reinforcement learning, ensemble learning. Again, it is like neural net and deep learning. There we told something called convolutional neural networks, then recurrent neural network, some LSTM, gated recurrent units. Then we studied something called generative and adversarial networks, then autoencoders, then perceptual, started with perceptrons, and learning with critic or learning from the environment is the reinforcement learning. Then we have classical learnings as opposed to machine learning. In classical learnings, we have two categories: unsupervised and supervised. Unsupervised is for clustering, supervised is for classification and regression. Regression is basically for prediction, forecasting. And in case of unsupervised learning, it is meant for searching the patterns. And again, there come some concepts of generalization. To improve the generalization capability of the model, we expect that training examples dimensions should be smaller. In that case, sometimes some people will teach something called dimension reduction. Again, dimension reduction is nothing but something called pattern compression, reducing the dimension of the pattern to a lower dimension by preserving the maximum information which is there in the signal. That is done by using classical method like principal component analysis, latent semantic analysis, singular value decomposition, linear discriminant analysis, and so on. These are all the more or less like we are touched upon yesterday, but then moving further, deep network. What are these deep network? The neural network, we have multi-layer. Normally multi-layer corresponds to 4 layer, but now say for example here we have 5 layers, input layer, output layer, and 3 hidden layers. Therefore it's called multi-layer. This, see, once upon a time, researcher used to use multi-layer means 2 hidden layer, 1 input, 1 output. It is expected to capture the nonlinear decision surface, but it has some limitation. Therefore, to learn deep features, people went for deep layer networks. But learning algorithm remains the same, backpropagation algorithm. But problem with multi-layer, the deep neural network is that when you are having large number of layers, notice in order to adjust the weights, in case of multi-layer feed forward neural network, we use something called backpropagation algorithm. Gradient of the error propagated back to adjust the weights. That's why it's called backpropagation. When I have the gradient very small, when it passes through the various layers, it becomes smaller, smaller, smaller. Finally, when it becomes 0, then that like spoils the computation. Value becomes 0 of a kind. That is called Vanish gradient problem. It is there with respect to deep networks. And if the another case where when you have the gradient is nothing but derivative of the error. Error is nothing but actual output and desired output difference. And that if that error is very, as a gradient is very large, then it starts becoming more, it explodes, it goes to infinity. That is called exploding gradient problem. To deal with exploding and it's like vanishing gradient problem, we have something called selective attention, at the same time skipping some of the layers, jumping, and sometimes something called regularization parameter or activation functions first are like different, so that there won't be any saturation of the output. This is the thing with respect to deep network, one has to take care of a kind. And earlier researcher used to use all the data at a time to feed to the network. That is called entire day, one epoch. And rather than doing that, one can divide the training data into many batches. Then one batch at a time can be given and adjusted the weight. That is called batch learning. And randomly one can pick the input data and train the model. So that is called stochastic processing. Those are all the tricks and trades like researcher use to deal with the deep networks to do things better. All right, whether it's a deep neural network or multi-layer, it is a multi-layer feed forward neural network. Next, people talks about something called nowadays data science, big data, data analytics. You know, to train the models, either using statistical methods or neural network methods, you require large amount of data. Data is like gold. It is very precious, and in this regard, a different direction itself evolved. There is something called data science. You know, there is a branch nowadays engineering. I don't know in how many colleges it is there. That is called artificial intelligence and data science, AIDS, or even MTech specialization in data science, big data analytics. So many these things you might have heard. Big data. This is a big data analysis. What is the advantage of having big data? Big data, when you have large amount of data, once upon a time it was not possible to get the large amount of data. Nowadays it is possible because so many sensors are there, so many video cameras are there, so much social media data. There is a Huge data is there, unsupervised and supervised. So much amount of data is there. And dealing the data, you definitely require different algorithm, different even computer architecture of the computer itself should be different compared to what we had earlier, 1990s or 2000 of it. Big data is like elephant, and what is associated with the big data is that where since the data is large, there is a variability in the data, and variability in the data becomes advantage because network can learn in various conditions. Variability, something called variety, different type of data, and volume of data, veracity of data, all those things associated with the big data. And next is data science. Data science and data, big data, then another terms come data analytics. Analytics is finally you are using mathematical like methods or approaches to analyze the data, finally make some sense of the data. Now, there is like data science is there, data analytics is there, data big data is there. Somewhere I have collected this sign. See, below you see data scientist. The data scientists are paid $130,000. That is at and about $10,000 per month. It is a huge. There is a professor in USA can get that much salary per month of account. Data analytics, half of that. Big data, this. Therefore, data science studying is very important because of various reasons. There, say, what you require in data science is you require the knowledge of this, say, Python to deal with this one, and so many these things of account. Say, for in data analytics, we require knowledge of R. R is a, I think like MATLAB. That is a software. Big data is like your database management system. No SQL, Hadoop, then like HV, all those things. Okay. Now, data science is a broad area where scientific methods, mathematics, statistics, and a host of other tools are applied to data sets in order to extract the required knowledge and insights. What data consists of? Data is coming from a source. It represents some insight or some characteristics of this source. This data science applications are vast. For example, advertising and marketing, automatically, search engines, and delivery logistics, and fraud and risk. In such cases, data science knowledge will be useful. Therefore, data science, it requires knowledge of computer engineering, innovative technology, scientific thinking, statistical methods. Similar things are written here. In 1974, when this computer science was like field was emerging, that time actually people thought this branch itself should be named as computer science, data science. Then people thought data science is a little bit lower word. It is not that, it won't give that much like name and fame. Therefore, they call it as a computer science. But actually, it is a computer science is a data science. We know very well computer is a what you call a data processing machine. That's why once upon a time we used to not only once, still till now it does only text processing. Then people used to study COBOL. COBOL means language, business oriented language. Then to some extent Oracle, DBase, DBMS, all those things. Those are all like a computer does the task effort without tired. Therefore, these are the things related to data science. Since it involves many things, therefore this gives something about data science, big data, math pattern, engineering, visualization to analyze the data graphically, and these are all the things comes with respect to data science. Coming to big data. What is this big data? Large volume of data that cannot be analyzed using traditional methods. For example, like why now people says that Hadoop, all those things. So why this came? People used to use earlier COBOL. Now nobody uses COBOL because those are all meant for serial file, sequential file, random file, and same index file organization, all those things. When data is small, those directions are okay. But when the data is large, you need to have different way of storing the data itself in that, and a way of like keeping it backup and maintaining the security, maintaining the integrity. Those are all these things changed because of the large amount of data and volume of data. No more traditional methods are existing. Application of big data is industries and areas, for example, e-learning, finance industry, and internet. Coming to something, it is related to our discussion today, is the data analytics. And in this data analytics, what happens is, say, data analytics can be said to be nearly similar to data science, but the difference, but it has more focused role in comparison. In data analytics, analysis of data is concentrated in specific area with specific goal in mind. For example, in business intelligence, how data science is dealt. Dealing with the data science means what? We have the big data, how to process, how to analyze, and how to what you call represent, interpret, and so on. Data analytics applications are in business intelligence, travel, hospitality industry, healthcare, and so on. That's where our like medical image processing application comes into picture. So most of the time we use data analytic methods for the healthcare, hospitality index, medical image processing, and so on. When you see a typical syllabus of the data analytics, what is done is, say, introduction to data analytics and visualization. Visualization is very important because we know that when you have a result in the form of table, you may not make out many things out of that. But when you have a plot or figure or say some you can say chart, that gives more insight. There is a saying that one picture worth about 1,000 words of a kind. In this data analytics and visualization, overview of data science, data analytics, data warehousing, data mining, and business intelligence. How to collect the data. Data curation. Curation and modeling means it is to be what you call labeled, and it should be cleaned. Descriptive and predictive analysis, application in visualization, forecasting. Forecasting corresponds to predicting well in advance from the given time series data. Recommendation system, social sciences, and intersection to R language, that is like MATLAB, C language. There is a R language, and that is very much well suited for analyzing the data, and basic statistics are reviewed. That is about data analytics and visualization. And predictive analysis, what is done is classification, clustering, and we use something called distance measure and similarity measure to find the error between the desired output and actual output. There are different kinds of clusterings, hierarchical clustering, K-mean clustering, and so on. And the classification, you may be using support vector machines, and this support vector machine deals with the data in high dimensional space. And as I said, there is a dimensional reduction technique because to reduce the dimension of the pattern vector to reduce the computation complexity and requirement of the large amount of data. And there are something called regression and correlation methods. Correlation method is used to measure how similar the two sequences are. And there you will be having something called Pearson correlation coefficient and autocorrelation methods, and so on. And we have something called time series analysis. Time series, how to find the trend. For example, how like whether forecasting department gives an indication that possibility of raining, heavy raining, all those things are there. And that is done by finding the trend or analyzing the trends in the given data. And seasonality corresponds to with respect to a particular season, say rainy season, this will be the trend, winter season, this will be the trend, and so on. And in this, we have something called autocorrelation methods, auto regression, and like moving average methods, and so on. And we do something called frequency analysis, spectral analysis. These are the frequency content of the signal. Frequency, roughly, you can say something which is repeating effect. And to derive that, draw the conclusion from the result, then something where we use statistical inference. Whatever the result you get, you do something called zero hypothesis, null hypothesis, and testing hypothesis effect. That is, what extent I can believe the result, whatever obtained with respect to a limited data, it is still valid for large amount of data. In that case, we'll be having something called significant test, that is T-square significant test. There's something called confidence interval, and so on. Then all these things, normally this data analytics be useful in the in computation linguistics is nothing but text analysis, mining, and so on. This is about data science, data analytics, and big data analytics. Coming to machine learning, how it is, that is, these are all machine learning approaches. These are all, for example, when you go back to this here, whatever you have studied, that comes under somewhere, say regression is there, classification is there, dimension reduction is there, then statistical methods like the neural methods, classical methods, supervised methods, regression, classification, and so on. Now, what are some of the, say, problems they tackled, at least in biomedical signal? Biomedical signal processing is sometimes it is called as biomedical image processing. Machine learning approaches in biomedical signal processing. So biomedical signal image processing, it includes what? In biomedical signal processing means what? Or biomedical image processing means what? It includes analysis, enhancement, and presentation of images to be captured via X-ray, ultrasound, MRI, nuclear medicine, and visual imaging technologies. These are few of the biomedical signal processing methods. There are so many other things, but people thought these are all little bit difficult to deal. These are all the complicated problems compared to like other methods of it. And machine learning in biomedical signal processing, it involves what? It is practiced to build computational intelligence models directly from the biomedical signals. And so for example, the computational intelligence models directly from the biomedical signals we are going to build. That is nothing but biomedical signal processing. Now just I will display one file. What is that file? MLFF ROB. Take this. If people are able to see this PDF file. Hello?
Yes, sir. Yes, sir.
There are so many special issues in journal, conferences, all those things. I have seen for machine learning, for biomedical signal processing. Machine learning, how can I use it for EEG signal processing? How can I analyze ECG, EMG, brain-computer interface, that is reading the signal from the human brain, then human-machine interaction, then neural habitation, signal processing for big data. all those things, signal processing for brain machine interface, biomedical signal processing, machine learning for signal processing, machine learning in biomedical application, all those things. And there are even special issues, and like what you call, even like there are so much what you call progress has taken place in this direction. Frankly speaking, this machine learning and AI approaches became very handy in some of these areas, say biomedical signal processing, computer vision, and healthcare, even civil engineering, analyzing the structures, then mechanical engineering, analyzing the various machines, because we don't have direct methods, don't have analytical methods, direct from solutions in these cases. When we have data, huge amount of data available nowadays, then we can train the models. Therefore, people, researchers are like experiencing importance of machine learning in these areas, and that became very like handy for all these things. Coming to particular this one, you see, biosignal learning and synthesis using deep neural networks. I will like take this what you call. I will show one more. This one. What is done here is that see these researchers, the present work in this explores the gated recurrent neural network, a type of neural network called GRU. There we have different kind of recurrent neural network called long short time memory, LSTM, then Elman neural network and gated recurrent network. Gated recurrent neural network they have employed in training of respiration, electromyograms and electrocardiograms. Why they have used this is the following. Sometimes it is difficult to get this kind of data from the patients. You cannot collect large amount of patients. Therefore, when I have some amount of data collected from the patients, then I can train the models to synthesize the ECG signal itself, EEG signal itself. For that purpose, people use the deep what you call gated recurrent neural network for this task. See, each signal is preprocessed, segmented, and quantized in a specific number of classes corresponding to the amplitude of each sample and fed to the model, which is composed by embedded matrix, 3 gated recurrent blocks, GRU blocks, and softmax. This is an activation function. This network is trained by adjusting its internal parameter. They are called hyperparameters of the network, acquiring the representation of the abstract notion of next value based upon the previous ones. That is, they used predict the next sample value or amplitude in the signals. The simulated signal was generated by forecasting random value and refeeding itself. Therefore, researchers have used to synthesize the biomedical signal itself by learning some of the biomedical signals initially, then that train model synthesize that, because training I told right, for training the model you require large amount of data, but a large amount of data getting is difficult. Therefore, can I what you call synthesize the data, so that synthesized data is almost similar to the near to the like natural data, then you will be having a lot of like generate GAN networks. They can be used for like synthesizing the data. Okay. Next, some researchers have explored what you call determination of hepatotropic virus in human metabolism using artificial neural network. I don't have much idea about this hepatitis virus we know, it harms to the patients and in human metabolism system. For determination purpose, they have used artificial intelligence. And there is constructing neural scenes from fMRI pattern using big GAN. That is, say, generator and adversarial network GAN. By using this neural network, they reconstruct the natural scene from fMRI patterns. Therefore, like it became very useful. GAN became very useful for reconstructing the natural scenes, and otherwise it is very difficult to reconstruct the natural scenes from fMRI patterns. Because of the advancement in the technology, neural network, this one, it made possible to do some of the studies which were very difficult some years ago. Then another studies where people have used something called diagnosis of liver disease induced by hepatitis virus using artificial neural network. And other study, there is yesterday I told different kinds of network, convolution neural networks, there where we have a convolution layer and a feed forward layer. We explore, for example, convolution layer for analyzing the audio scenes, various in which environment this signal has been recorded effectively. Convolution neural network. What happens in case of convolution neural network is that initial layer that is used to extract the suitable features. We don't know, say, what is suitable feature, what is not suitable for a particular task. We ask the network itself to learn the suitable features and initially using some of the part that is called convolution layers. And convolution neural network are explored in biomedical signal processing convolution, and that is, I will display this one so that EF thing. Yes. Maybe I will make a little bit bigger. 100%. Yeah. Let us see what is done in this study of CNN for various tasks. These are all these basics of the CNN. You need not have to worry. Yeah. See, for easy signal analysis, they use CNN. ECG signal analysis, they have used the CNN. And EMG analysis, they have used the CNN and so on. That means, see, what happens is, once I have the signal, I extract from the signal. It could be, for example, speech signal by using microphone, or it could be, say, for example, face recognition, all those things by using camera, or say from fMRI or X-ray. When you have the signals, further, when you have the problem domain knowledge of that area, then these deep neural network approaches or machine learning approaches becomes handy, irrespective of the field. Then, see, various researchers uses these machine learning approaches. But what makes, say, well, though I know machine learning, but I cannot do much more in the, for example, in case of biomedical signal processing. Assume that you know machine learning, you cannot do much in the speech processing. We know something, but we cannot do, for example, seismic signal processing that is related to earthquake, all those things. Problem domain knowledge is very much important. When you have the problem domain knowledge, that is knowledge in the particular field, then when you apply this or when you use this, it becomes easy for you to analyze why that method is working, why it is not working, and so on of a kind. That's where like expertization of a field comes into picture. Even in the medical, this one to develop a expert to develop expert system, say artificial intelligence based expert system, knowledge has to come from the expert of that domain. Right? For example, this what is called AI based that chess in 1992, it has defeated Gary Kasparov. That is the champion. We can't call them champions. We are called grandmasters, and the people who are topmost in the this one in chess they are called grandmasters. For example, in the sports they have different this thing of a kind. Sachin Tendulkar, cricket, he is a superstar in the cricket. Film, movie, this one, they are superstars. In that way, we cannot call them as superstars because see there is a different field. It is a grandmaster. Computer defeated grandmaster in 1992 to what you call Gary Kasparov. I can show that this one. Yeah. This is, I can close this. That okay. Gary Kasparov. That computer is called. Computer difficult. Human computer just messes. For example, here. Mimic 56. These are all the where your AI started. Tech 98. There is something called deep thought. Deep thought is deep blue is the one it has defeated. Just this is a Kasparov, deep blue. What happened is, say in this making AI for say chess playing, it started in 1989, and deep blue is that is a IBM machine. Deep blue is nothing but IBM machine computer that is developed. See there, this one. What happened initially? Say one Indian also very famous one, Anant Raman, I think is IIT BHU alumni. He was a faculty in Carnegie Mellon University. That time they developed something called deep thought. But deep thought has played with the Gary Kasparov. Gary Kasparov is a grandmaster in chess. That time he defeated that computer. Then what IBM did is he hired previous grandmaster, and then they utilized knowledge of the previous grandmaster to develop or to enhance the system to defeat this Gary Kasparov in 1996. That's where problem domain knowledge becomes very handy. So when we have the methods, when we have the approaches, without knowing clearly what is we should be able to analyze the result. We should be able to change the parameters, all those things. That's where problem domain knowledge comes into picture. Otherwise, all these algorithm methods are available in the net. Within two minutes, you can download and run a fake. As a researcher, where our contribution lies is that for a specific task, which algorithm is better. So if it is working, One should be able to say it, why it is working, why you got a good result. Somebody says, say, support vector machine gives good result than this multi-layer feed forward network. Or somebody says CNN with 4 layers will give good result than 3 layer. Why it should give good result? And that's where some area is emerging, that is called explainable artificial intelligence. Meaning is that what is happening with respect to each layer, it cannot be used as a black box. If one should be able to say this layer is doing this, this is capturing this. When I go from 4 layer to 5 layer, it has given the improvement. Why it has given the improvement? What made the network to give the improvement? From where improvement is occurring? That is called what you call explainable artificial intelligence. Now that is also one of the field and researchers are working in that area. Mallikarjun, I thought I can discuss this much. I have only this much to say.
Sir, thank you, sir. Sir is busy with meeting, sir. Actually, today VC sir meeting is going on, sir.
Okay.
So, shall we take up questions, sir?
You can take questions. You can ask somebody if they have any doubt.
Yes.
Yeah.
Sir,
Hello, sir. Can I ask a question?
Yeah.
Yeah, sir, actually, I want to ask, like while doing all those machine learning and data science and all those stuff, so we generally find the accuracy for the model what we develop. So to finding this accuracy, whether there is any specific way, like for if you are implementing CNN, then this should be the accuracy measures you should do. If you are using FLN, then maybe this should be the accuracy, the formulas you should use. Whether anything like that, or whether it differs from application to application, or it should be standard, maybe mean average percentage error, mean square error, that sort of thing. Whether it is like that, sir?
See, what happens is we do not have anything in advance in the hand that it should do this much of a kind. See, when you work in a particular field or in area, you will be knowing what is the current state of the art.
Okay.
Say at present somebody has achieved say 89% of a kind. Then says after some time this one will come, some other algorithms come, some methods comes, or these are all the various methods and these are all the various features, these are the various algorithms. Things will come by trial and error. Then you have some improvement over the benchmark. Then we should be able to say why this approach has given good result. But there is no standard procedure that nobody will get. These are all the black boxes. That is the tragedy of this.
Okay. Thank you. Thanks a lot.
Yes, sir. Yes.
Excuse me, sir. There are some questions are there in the chat box. Should I read for you, sir?
You can you read and tell me who is asking that question.
Okay, sir. Okay. Sir, one participant by name Shweta, she has asked, what do you mean by one epoch?
She left the meeting also asking question, I think. Okay, one epoch means the following. Let us say you have 100 training examples. Okay.
Yes, sir.
I will give one by one. I will train using one by one up to 100. That's over. But model might have not trained fully. Then I will start again from the first one. But I have presented all these training data, 100 training data. Then that is called one epoch. Presenting all the training data once, it is called one epoch.
Yes. Okay. So same person only, she has asked how to normalize the EEG data. What is the difference between deep learning and CNN?
See, deep learning is a general word. Deep learning is a general word, anything more than 4 layers. And CNN is one of the net algorithm or direction in the deep learning.
Yes.
Yes.
Yes. Thank you, sir. Sir, one by name Ramesh B. Which topic I want to select to do the PhD in AI, sir?
Actually, there is nothing like PhD in AI. We have to select a real world problem. Then we use methods of AI. Say there
Yes.
is say research in AI means your meaning is you are coming up with new say new model or new direction. For example, CNN somebody invented, but with our knowledge, we are engineers, so we don't have that much like background or this thing to do some research in AI. Using AI, we are doing our own research of problem domain. Say, for example, biomedical. You take some, for example, analysis of like patient. Somebody is like he's a normal or abnormal, or what extent like degree of normality. These are all like you people have done, for example, BTech, MTech in that area. Then you will be knowing there are some tough problems. Can I solve that by using machine learning algorithm? Therefore, problem you will be tackling with respect to your domain, your research area. You are using these tools and techniques or approaches to solve that problem.
Thank you, sir. One more by Sulekha madam. Which is more better to apply in heart disease detection, ELM or deep learning?
First one is what, madam?
ELM. She has written ELM, sir. I don't know. Sulekha madam, can you just elaborate on that? Sulekha madam? No, sir, she has not responded, sir.
Extreme learning machine.
Yes.
I am not aware of that learning method because what happens is, see, initially none of us will be knowing which one will work of a kind. So for example, if it is a time series analysis, again in time series analysis, recurrent neural network is there, linear prediction analysis is there. Again in recurrent neural network, I have 3-4 methods. LSTM is there, bidirectional LSTM is there, GRU is there, Elman recurrent neural network. We need to explore by trial and error. Without exploring, we cannot say this is better than that. But after getting the result, when you have one method, one result, another method say better result, now you can think and you can convince and provide the convincing description that why this method is working.
Okay, thank you. Sir.
Yeah.
Hello. Good afternoon. Sir, can you tell me one thing? What is the difference between the synthetic data and artifact EEG data?
It is the see, synthetic means you are totally generating from a method or algorithm. Artifact data is the data which has noise, but it is collected from the natural patient and the equipment.
Okay.
Yes.
Okay. Sir, one more question from Usha Aaron, madam. I am doing research on data analysis in healthcare, and she is from CSE, sir, and she has also thought of using association rule-based mining with NLP. Will it be fruitful path?
I think so, because that association rule mining in natural language processing is like nowadays coming up well.
Yes, sir.
Yeah.
And what is the difference between ANN and CNN?
Oh, simulating the human brain are representing like mathematical modeling the human brain is artificial neural network. All the CNN, RNN, deep network, all these things are type of artificial neural network. Artificial neural network is a general word.
Yes. Sir, one from Snehal Kulkarni. Whether CNN is preferred only for EMG, image data?
No, it is not like that, because see what happens is CNN, it has initially some layer called convolutional layer, then followed by feed forward layer. In case of convolution layer, from the raw data itself, it extracts the features. Therefore, like the features which are suitable for the task. Say when you don't know what kind of features I need to extract, then you use CNN.
Yes.
Yeah.
Again, Shweta madam only. How to analyze EEG data?
That somebody from biomedical department should be able to say. I am not. Analysis means what? It is for what purpose? I don't have idea about that. Yeah.
Okay, sir. One more participant, Kulkarni. Designing algorithms like knowledge representation searching to be part of research in AI. Is it correct, sir?
Yeah.
Yes. Again, some same person. In CNN and deep learning, only the layer prior to softmax has back propagation. It is not from output to input of CNN. Is it, sir?
See, maybe I will open that CNN so that people can understand and appreciate. Yesterday, this one was there. Nowadays, like that CNN is very, many people are exploring that. So that. Okay. You are able to see the screen?
Yes, sir. Yes, sir.
What is there on the screen?
CNN slides, sir.
Okay. See, up to this, see, fully connected layer is there, na? FC4, FC3.
Yes, sir. Yes, sir.
This is feed forward neural network. It can be 4-layer multi-layer feed forward neural network or deep neural network, or it can be SVM or anything. CNN means here is the major contribution. And here what is happening is features are extracted. There is not that much like learning method is involved. Here the features are extracted and features are fed to this network. This entire thing is called convolution neural network, and this is feed forward layer, and this is the convolution layer, fully connected layer, and this is the convolution layer. And see, input you are giving. What is the advantage of CNN is, see, I don't know what kind of features I need to extract from the given data, which is suitable for my task. In that case, we are asking this network itself to extract the suitable features by say convolution method, all those things. This is CNN. Any other questions? Hello? Hello?
Hello.
Ah.
Hello, sir.
Yeah.
Hello, good evening, sir.
Yeah.
Sir. I am scholars from PD Engineering College, Kalburgi.
Your name?
Shweta, sir.
Okay, madam.
Yeah, sir. I am research scholar. I have collected EEG data from hospital, sir.
Which hospital?
And in our city hospital, government hospital, sir. Yeah, the EEG data I have collected more than 10, sir. In seizure patients. My topic is seizures, classification and detection.
Okay.
Seizure patient and non-seizure patient, I have collected both. But that data will be pre-processing, sir. And now I have started the work. And how to normalize the data in pre-processing, sir?
The pre-processing means you need, what kind of pre-processing you usually done?
Sir, that data will be I have collected from neurocomputing software in that hospital. And the data will be clear. It will look like say is a seizure and non-seizure, depends upon the frequency band like alpha, beta, gamma.
I think there are some signal processing techniques you need to use for like removing the noise.
Yeah, I am using the SVM and the DWT.
SVM, I do not know whether SVM is used for pre-processing or not. Pre-processing mainly involves signal processing.
Yes, sir. And just I have collected the data, and what I am doing next, I did not understanding.
Now do one thing. As it is, you train the models using that, you get the result how it performs, and you see whether it is a clean data or say some noise. You need to do pre-processing.
Some artifact is there, sir.
Artifact is there. Then signal processing will be useful. For pre-processing, networks are not that much handy. With whom you are working? PhD. Who is your PhD advisor?
Yeah, Nagendra, sir.
Where that sir works?
in PD engineering college only, sir.
So your faculty or student there, or both?
Yeah, I am student, sir.
Huh?
Research scholar. Full-time research scholar.
Where you did your BTech?
Engineering Bidar.
Which college?
Guru Nanak Dev Engineering College.
Okay, I am also from Bidar. I did my PUC from Bumradi College. Then my native place is Vannadi. I got my first BTech in Guru Nanak Dev Engineering College in 85. Then I did not go
Okay,
because
okay.
somebody says there's a lot of fee 8,000. Therefore, I went to Davangere. I know Bidar.
Okay, okay.
Bidar. Then through that Guru Nanak College, I used to go to my native place through. Some Mylapore forest is there, right? What is Amlapur forest? What is that? Some
I have
forest.
completed in BTech 2013, sir, pass out, and regular is there.
MTech?
MTech 2016 and 17 PhD joined.
17, what is done, madam?
And PhD, sir.
Okay, okay. MTech from which college?
And BKIT Valki, Bhimana Country. Institute
Oh,
of
I
Technology.
know there. I came 2-3 times to give presentation also. So, I know.
Mallikarjun Holi, sir, is alumni for PDA College, sir.
I know. He completed in 93.
Yes, sir, in PD, our college only, sir.
I gave even interview in that college.